Pull up the wiring diagram, and I'm talking through it to him. There's no wire on T1.
That's timer. One minute.
That's what starts the timer. So it shows you right here. When a Y call comes in, it sends out a Y call. The Y call goes through the low pressure switch, the high pressure switch, comes back, activates T1. T1 starts your timer, and then puts it out on T2, which starts the compressor. Somebody had decided to take T1 and pull it out and put it right there.
Straight to the contactor.
Yep.
Yep, and so the contactor had T2
Yes.
and the T1 wire on it, so either one could bring it on.
It'll never go.
And so it'll never go into defrost, so the timer never got started. And so when I start talking to him, all right, it should be a wire on T1. He said, there's not a wire on T1. So we start tracing. And I said, well, there's a wire on Y1. He pulls Y1 off, the unit shuts off. I said, well, I have a feeling they took that wire and went straight to the contactor, and we traced it down, and that's exactly what they did. Because when they pulled Y1 off, Y1 should have never turned the compressor on by itself anyway. Yeah, well now he left it through the pressure switches.
Oh, okay.
Yeah, but he just bypassed the timer. He went from here to here.
Okay. Got
And
it.
so the board knows I've got a Y call going out, but I don't have a Y call coming back. The board thinks that one of these pressure switches is open. And so that's why we would never get a defrost. And so the biggest moral of the story is if we can't find a wire diagram, like anytime there's an open terminal, I imagine what happened was somebody somewhere, may not have been us, bypassed it. And when we got there, it was probably summertime or something. And they just went straight to it. They couldn't figure out what was going on. And when we got there, we replaced the board exactly like we found it. But whenever you see an open terminal, probably need to verify your wiring schematic to make sure that it's supposed to be an open terminal. And then definitely after we replace it and continue to have issues, you couldn't even get it to short in the defrost, could you?
Nope.
So whoever replaced it the first time never, just run a short to make sure it's going to bring on the, switch a reversing valve and do all the things it's supposed to do. So we also need to test it. Yeah. That was my biggest thing is use Google. So it was a 604D something another Bryant unit, 604D install manual, and that pops up. Found the wiring schematic, and luckily that was the right one.
Scott, for a residential unit, a two-stage, would a high efficiency filter affect and cause high pressure lockout?
It could. A lot of time you got ECM motors, and so those can overcome a lot of things. This is a commercial unit, so you got what you got.
Okay, but residential?
But residential, it could or couldn't, because you got ECM motors, they can get up to a 1-inch static pressure, instead of a 1/2-inch static pressure. But on any particular unit, we should be able to know what our temperature rise is. If I got there we go, learn some math today. If I got an 80,000 BTU furnace, MBH, all right, and it's 95% efficient, all right? So it's putting out 76,000 BTUs of heat, all right? And it's on a 3-ton unit. So my CFM should be about what? About 1,200. All right, so 76,000 divided by 1,200 divided by 1.08, 58.6. So if I've got 70 in, I should have 138.6 out. If I got 70 in and I got 160 out, I can do the other way. All right, if I got 70 in, 160 out, that's a 90-degree rise, right? So 76,000 divided by 90 divided by 1.08. I got 781 CFM instead of 1,200. I got a problem. Now, with gas, it's not an exact science because it may or may not be 95% efficient. It may be old, but it's a roundabout. But those of you who've been here before, with electric heat, it is an exact science.
Makes sense, yeah.
And we remember that formula, right?
No.
Exactly.
Alright, so this is CFM times delta T times 1.08 equals BTUs.
Now I remember.
Alright, that's how all this comes.
Write this down.
This is how all this comes about. Alright, the only thing that's different in electric is there is 3,415 BTUs per kW. How do we find out kW?
Just look
Sync.
up there.
No, we're gonna actually measure it. kW equals amps.
You can't read it.
Amps
Oh, I see.
times
Okay.
volts.
Yes.
And that equals, actually that's watts. So amps times volts divided by 1,000 is kW. Alright? If it's three phase, watts equals amps times volts times 1.73. And so, once I know my watts, I can figure out my BTUs and I can use this formula. And that, on the electric heat, is exact. I mean,
Also, electric is 100% efficient. That's why I tell you, guys, lean on us. Between Scott, Skip, and heaven forbid you ask me a technical question, they have the answers. You with me? So any problem you run into, we can help. Between the professional engineer brother, who is very rare to have a professional engineer who has actual install experience.